All right, welcome back to Bert's Basics. Today we're going to finish the eyeball. So we're still doing special senses eye, and we're focusing on the nervous tunic today and diseases of the eye. So let's look at what we got to learn today. So these are the things we have to learn today. We have to focus on the nervous tunic, like I said, and then these are the list. Sorry, I should have got that page out of there. That's the list of all the diseases that we're going to try to talk about now. And if you have not watched the eye video before this, you probably should. In the last video, we talked about the fibrous tunic being the sclera and the cornea. Then we talked about the vascular tunic with the ciliary body, zonular fibers, the lens and the iris, and we talked a little bit about the pupil. We talked about glaucomas, cataracts, and astigmatisms. So if you haven't watched that video, please watch that one because this one won't make as much sense because I'm jumping right into the nervous tunic. So if we start on the superficial part of the eye and work our way in, we start with the sclera. Remember, the sclera is the really thick, strong white part of your eye. Okay, and then after that, we get the C for choroid, which is the vascular part of your eye. That's where all the blood vessels are found. But now we're focusing on the nervous tunic. And the nervous tunic, we're really focusing on just the nerves, and this is called your R for your retina. So let's look at your retina really quick. Okay, your retina in yellow is where all your rods and cones are. Now, you might not be familiar with the words rods and cones, but think of them as just special neurons that sense light. Now, there's one place on your retina that has the most crystalline, perfect vision out of anywhere. And it's called my central fovea. So that's your fovea right there. So see this little indentation? That's where light should come in through the cornea, through the pupil, okay, through the pupil, which is controlled by the iris, remember the dimension, then by the lens, and remember my ciliary bodies can help change the shape of my lens to help me get what I need to do, but everything, okay, they should focus on my fovea. Now, this region where the fovea is, where I find most of my neurons, is called my macula. And we're going to talk about where rods and cones are located before, but I'm guessing you've probably heard of the word macula. So our goal is to have all the light that comes in through our eye hit this central fovea. Okay, that's where we want to be. Then we'll talk about what all these yellow guys are in just a second. So what ends up happening is, here's maybe a better picture. There's your central fovea right there. And remember, in my central fovea, we have a place called my macula. Your macula is the region where you have a dense collection of neurons to capture the light. So this is my basic vision. Now, if I see over here, if light hits here, I can perceive it, but it won't be as crystalline focus as it would if light hit my central fovea, which is right there. Okay? And then we'll talk about what my optic nerve is in a second. So to get this, you have to master rods and cones. Okay, these are specialized neurons that help us see. Okay, so we got to know where they are. So obviously you can see why they call them rods, and you can see why they call them cones. Okay, because they're named after their shape. Now, the eyesight, the way it detects light, is a lot different than what you think. But the most questions you're going to have is just basically what do rods and cones do. So here's what I want you guys to know for cones. Cones, CC, cones sense color. Cone sense color, cone sense color, cone sense color, cone sense color, cone sense color. Okay, C, 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 C. Now, every teacher teaches rods a little bit differently. Most teachers I've ever had say, oh, rods are black and white then. Okay, I will let you have black and white, but I really don't want you to have black and white. I want you to learn rods more as the presence of light. Yes or no? The presence of light. So say you're going on a walk in the woods. They say you're camping and you're walking up in the woods. You can see trees, you can see leaves, you can see movement of the leaves. You can even see depth perception. You know how far away that bush is. The problem is you might not know what color the flowers are. That's what I want you to think of rods. I want you to think of rods as the presence of light. Can you actually see if light is present? So this goes to tell that your rods then work best during the nighttime. Your rods are your nighttime vision. They're going crazy. During the daytime, they take a break, and then your cones catch on guard. Your cones are your color vision. So now let's talk about how this works. Now, this is really kind of crazy. You'll learn a ton about this in Weber. In this class, we don't need to learn too much about it. But the light, when light comes in, this is kind of crazy. It actually hits the back of your retina. So here's my retina right here. So the light comes all the way to the back of the retina where it gets absorbed by this pigmented layer. Then the pigmented layer, through a series of chemical reactions called opsins, which we'll talk about in Weber, they make these dendrites fire. And then the dendrites send it to the cell bodies, and then they send it out on these axons. Can you see all these axons? Now, if I have all these axons leaving, axon, and axon, and axon, and axon, and axon, I have to have these axons go out somewhere, and they do. They go out right here. Do you see that big back part of the eye? That is called the optic nerve. So what ends up happening is the light goes all the way back to the back where it gets absorbed. Okay, then it triggers either the cones for color or the rods for black and white, which I hate black and white. Let's say presence of light. And then the axons are going to come out and they're all going to leave together. And this is one of your cranial nerves, and this is the almighty optic nerve. This also goes to see why we have blind spots. If you notice, there are no rods and no cones on the optic nerve location called your optic disc, right? So our eyes compensate for that, but we can do fun activities, which you'll do in lab, to figure out where your blind spot is and why you have a blind spot, and depth perception, which is really cool. Okay, so once again, I know I want to teach rods and cones a lot better. There's a lot more complicated in what goes on, but for this class, you need to know cones will be the ones who sense the color, and rods will be the ones who sense the presence of light, aka black and white vision, if you rather. Okay, so we've already done these guys here. So we got here rods are elongated cylinder dendrites, varying light conditions. I like this one. Night vision allows to see us in various light intensities. That's not that bad to me. Cones, on the other hand, okay, they're tapered, and that's what they're looking for. Color sensitivity for cones. Okay. Talk about that later. Cool YouTube videos. Talk about that later. Okay. I think we're okay. Blind spot we already talked about. I think we're okay there. Let's go. Oh, this one we got to talk about right here. Okay. Unfortunately, your eye changes. Okay. Sometimes people are born with a longer eye. Some people are born with a shorter eye. But this should make sense. So I have my cornea, which is part of the outer eye. I have my aqueous humor, vitreous humor, which we're okay with. I got my lens, my ciliary body. Do you remember how we said everything has to be focused on this central fovea right here? That's where all our vision wants to be. Well, look at these two problems below us. That's a problem, and it generally is the shape of your eye. That's generally what it is. So if we go ahead and look at this first one. This first one's called myopia, and the second one's called hyperopia. Okay, and so we got to make sure that we get these two words down because they're going to be on your test. So what ends up happening is, okay, our goal, okay, don't forget C and D. I don't care about these guys. This is how we fix it. I care about the problem at hand. If you look at myopia, sometimes due to the shape of our eye, it focuses before it needs to, before the central fovea. So it's supposed to actually focus here. Okay, can you see this red line right there? But it focuses ahead of it. Okay, so what do we have that? That's called nearsighted or myopic. Okay, myopic is when you focus the light before the central fovea. Or look at the other one. If I was drawing this, man, I would draw it way back here. Let's say it focuses way back here. Do you understand? If it focuses way back here, you're way beyond the central fovea. That's what hyper means. Hyper means excessive or beyond. So this is called hyperopia or farsightedness. So when you guys go to the doctor, they're just going to see whether you are myopic or hyperopic, and they're going to see what corrective lens they can do to help you focus the light on your central fovea. That's what they're trying to do. So now we have three different opias. If you watched the last video, we did presbyopia. Presbyopia, can I go back to my camera here again really quick? Do you remember presbyopia? That's when the lens doesn't move very well. So you give your report card to your dad, and he's like, oh, no, I can't see this. So then he has to change the dimension of himself. That's presbyopia, okay? But if this is my central fovea, and the light's coming in this way, and it focuses too soon, we call that myopia or nearsightedness. Or, whoop, sometimes that part goes way too far behind the eye. If I do too far behind the eye, we call that hyperopia or farsightedness. Now, those words are hard. I get it. They're just going to be tricky, so make sure you guys get those really good. Okay, let's look at the other diseases that we're supposed to talk about in this unit. Okay, so we already talked about those. Let's see. Okay, ametropia. We got ametropia is just different. It's just different types of vision, I guess. Sorry, someone just walked in. Okay, so once again, I don't remember where we were. Let's go back to ametropia. Ametropia is where you just have some kind of different kind of refractive error, I guess you could say. So it doesn't really focus the light exactly on the retina. And then these are our guys here. So myopia, that's nearsightedness. You focus in front of the retina. Then we have presbyopia, which is a problem with advancing age. Oh, I don't want to get old. Okay. Or basically what's going to happen is you're going to struggle with that to, get it focused. So that's what old man disease, what I call that. Presb is elder. Okay. So this is elder vision, if you want to look at it that way. Okay. And then we got hyperopia, which is farsighted, which means it focuses in the back of the retina. Okay. We talked about cataracts in the last video. That's loss of transparency in the lens. It's not a question of if, it's showing a question of when. So then the vision can become blurry or cloudy. Wow, it's been a long day. Conjunctivitis. We showed you a picture of conjunctivitis in the first video, and it was really, really nasty. Remember, conjunctiva is what connects your palpebra, which is your eyelid, to your sclera, which is the white part of your eye. And when it gets inflamed, it's conjunctivitis, also known as pink eye, which I'm pretty sure that is actually your question on the quiz. Okay. Strabismus, cross-eye, we didn't talk about that one too much. We did talk about glaucoma. Okay, glaucoma. And remember, you have fluids in your eye. You have your aqueous and vitreous fluids, and they do drain into the venous sinus, right? But sometimes the fluid doesn't drain, and glaucoma is characterized by don't forget about this one, intraocular. That's inside eye pressure. And then what happens is it can cause atrophy without nourishment or without being fed to the optic nerve, which can be a problem. So if we have glaucoma, we definitely need to go check that out as soon as we possibly can. Okay. Macular degeneration. Now remember, we didn't really talk about this too much, but if we look at the back of your eye, okay, we had our central fovea. I'm just going to do it with an F. So if you remember, your fovea is where all the light's supposed to be focused. That's where you have the greatest collection of cones. So you have the greatest collection of vision is right there in your fovea. This region where you have the greatest sites for the nerves is called my macula. And the fovea is in the center of the macula. So if you have macular degeneration, it's exactly what you think the word means. Your macula is degenerating. Maybe it's got compressed. Maybe it's separating from the choroid. If you remember the choroid is the one right behind this that has all the blood vessels in it, right? So it says destruction or tearing away of the retina from the back of the eye. It's kind of scary. Okay, now there are a lot of cool techniques that we're doing to try to help fix this. But macular degeneration, something you just never want to hear. Okay, vertigo, that's going to be more with the ears, which we've already talked about. So congratulations, you guys now have finished the eye. So once again, I was going to give you questions on here because what I try to do is I try to usually give you questions, to do so I can make sure you guys actually did them. Instead of giving you questions, I think this would actually be better. These are two really, really, really cool YouTube videos about how rods and cones work, how they actually create a nerve impulse, how it's called transduction, taking it from one form to another. So if you guys really want to understand how rods and cones work with opsins and how vitamins play a role in vision and stuff like that, it is really, really, really cool. So instead of doing questions on this one, why don't you guys go ahead and watch these two YouTube videos? And once again, thank you for watching Burke's Basics, and I'll see you on the flip side.